The objective of this framework is to present a finite state machine represented as a Python software algorithm. In this video, I illustrate in general terms the required dependencies which I used in the development of this project. These software dependencies include the use of Pandas and Spyder IDE software development system and Python object-oriented programming language. The workload also includes design criteria for the implementation of an FSM finite state machine for a pattern matching application project. A finite state machine is a mathematical model of computation. It is an abstract machine that can be in exactly one of a finite number of states at any given time. The FSM can change from one state to another in response to some input. The change from one state to another is also known as a transition. So an FSM is defined by a list of its states, its initial state, and the inputs that trigger each transition. A state is a description of the status of a system that is awaiting to execute a transition. So, a transition is also a set of actions to be executed when a condition is fulfilled or when an event is received. For instance, in computer science, the finite state machines are widely used in modeling of application behavior. Implementation of a finite state machine with Python software models, with pattern matching used in this artificial intelligence application. Pattern matching is used for checking the correspondence of nested lists with a pattern. The matcher provides a powerful tool for operating on lists and makes it much easier to write lists processing programs. These are alternatives is to use the lower level facilities for manipulating lists. For instance, in Python, the head and tail of a list can be obtained with 1 equals open brackets 1, 2, 3, and 4 close brackets column. HD equals 1 open brackets 0 close brackets semicolon. TL equals 1 open brackets 1 divided close brackets. So the Python code to implement this project will be as follows. From pop matches, import matches, and MEXP. Then if underscore name underscore equals underscore main underscore column. Therefore, matches open parentheses open brackets 1 2, 3, and 4, close brackets, comma, open parentheses, MEXP, open parentheses, question mark HD, close parentheses, comma, MEXP, open parentheses, question mark, TL, close parentheses, close brackets, close parentheses again. Then the next step is print, open parentheses, HD. So in this code, the FSM, the finite state machine, is defined to check if a sentence input to the machine conforms to a simple grammar. The procedure recognize shown in the code in this video calls the recursive procedure recognize _ next to find valid transitions from start to node open parentheses S1 close parentheses to the final node open parentheses S9 close parentheses that are consistent with the input. The flow control is illustrated here. So first, recognized _ next is called with the current node and input sentence. Second, recognize _ next checks to see if a final node has been reached and the tape is empty. So the FSM exits with success, then the validity of the transition is checked. That is, if the variable tape is not equal to none. If the tape is none, then the function returns. Third, recognized _ next is called recursively for each of the possible transitions from the current node, which are retrieved by get _ transitions. So let's continue with the code explanation of the pattern matching system. So recognize _ next is called with two arguments. One, a new node, and two, the input tape advanced by one word, computed by recognize _ move. So the procedure recognize _ move is responsible for advancing the input tape if a transition to the new node is compatible with the word on the front of the tape. So the procedure returns the tape advance by one word, or none if a transition is not valid. So the code for the pattern matching FSM is as follows. From pop matches, import MEXP matches, import random. From pprint, import pprint. A _ equals MEXP open parentheses equals close parentheses. The class FSTN open parenthesis object close parenthesis colon. Output equals open parenthesis close parenthesis. The def _init _ open parenthesis self name args abbreviations tape close parenthesis, colon. That would be the self.name equals name, self.args equals args, self.network equals args, self.abbreviations equal abbreviations, self.tape equals tape, self.finished equals false. Part of the code is the def exit underscore from underscore fstn open parenthesis self close parenthesis column. Next line will be the raise exception open parenthesis exiting from finite state machine close parenthesis. Then the next line will be the def initial underscore nodes open parenthesis self close parenthesis column global v comma capital A underscore underscore. Then the next line is matches equals self dot network comma open brackets capital A underscore underscore comma open brackets initial comma MEXP close parenthesis open parenthesis question mark V as in Victor close parenthesis close brackets comma capital A underscore underscore close brackets close parentheses.